We're still in section 5.1 using properties of exponents, and now we're going to use exponents to solve scientific notation. So we worked on most of this packet already. If you go down to the bottom of the first page, there's one example here. Now I want to explain how they have these set up. This is scientific notation, and they're a little lazy about how they set it up. I want to show you what they really mean. This is how we should approach these problems. So this would be 6.0, the 6 here, times 10 to the negative fourth over 9.0 times 10 to the seventh. And we're going to split this into two parts. We're going to do the leading part, 6.0 and 9.0 together, and then the exponent part. Now, before we go any further, one thing I want to say, we've been told that no negative answers are allowed with exponents. Well, in scientific notation, we have a bunch of negative numbers. For numbers up between, again, back to your number line, here's your 0 and here's your 1. You have a bunch of numbers that the negative exponents like this represents. So it's okay to have negative answers for scientific notation. When we're dealing with the variables and the other bases, that's the problems we did in class, these have got to be positive exponents. Well, anyhow, 6 divided by 9, I know it's 2 over 3, which is, roughly 0.66. Put that in your calculator. And now dealing with what's going on right, we have 10 to the negative 4 and 10 to the 7th. Well, to bring that, I want to have this up in the numerator. I want everything to kind of be in the numerator, but that negative 7 has to come up as a negative 7. So this part alone here becomes 10 to the negative 4th. And I bring the 7 up, it's minus 7. So I have now 10 to the negative 11th. So 0.66 times 10 to the negative 11th. Well, I'm not quite in scientific notation here, am I? I've got to move this number, this decimal in here in one spot. So I have 6.6 times 10. Now I have to decide, do I make this number bigger or smaller? Well, I'm making this number 10 times bigger. I'm going from 0.66 to 6.6. It's 10 times bigger. So I've got to make this 10 times smaller. So I've got to make this 6.6 times 10 to the negative 12th. That balances that move of 10 from there to there. Okay, so let's try some other ones. This is my answer. Next page at the bottom, I think, well, yeah, at the bottom of the next page, second page, the skills practice, a couple of them we can do down here. Again, number 21. So again, I simplify the front end of this. Looks like 2.7 goes into those two. So that will be 3 over 2. You can divide 2.7 into both of those. Then I have 10 to the 12th and 10 to the 9th. Again, go back to what we did over the last few days. 10 to the 12th divided by 10 to the 9th. I'll bring that exponent up, I have to subtract it. So that will come up, that will equal 10 to the 12th minus 9, or just 10 to the 3rd. So the 8.1 and the 5.4 became 3.2. This part became 10 to the 3rd. Now that's not your answer. You can't do that. This is, you put it in a calculator, you get 1.5. So 1.5 times 10 to the 3rd. And now I got one number between 1 and 9 to the left of the decimal. Exponents ready to go. That's the answer. Number 22, let's keep going. I can divide both these by 1.1. So I would get 1 over 5. So 1 over 5. Now, this. Let's bring this 8 up. Well, if I bring the 8 up, it's going to be 10 to the negative 3rd minus a negative 8. That becomes a positive 8. So this would be 10 to the 5th power. Okay, not quite acceptable yet with this fraction. Again, putting into a calculator, I get 0.2, I'll say 0.2 for 1/5, times 10 to the 5th. I've got to get just got to have one number to the left of the decimal, and that's zero's not a 1 or 9, 1 through 9. So I got to bring the 2 over by sliding the decimal one place to the right. So now I have 2.0 times 10. Now I adjusted it by 10. I made this number bigger by multiplying by 10. So I take 10 away by dividing this by 10. This becomes a 4 now. You've got to balance out what you do from this side with what you do on this side. This got 10 times bigger by multiplying by 10. This had to get 10 times smaller. Therefore, I have a balance. We got some more to do. From the worksheet, this one here, we can go down to the bottom. There's a few more to do. And we have some multiplication here as well. So we're multiplying here. So this is going to take some calculator work, which I don't have in front of me right now. I'll get that. But again, you know, you get 10 to the third and 10 to the sixth, and the 5.7 times the 2.2. So if I get my calculator out, which I think I have here, 5.7 times 2.2. So 5.7 times 2.2 is 12.54. So 5.7, 2.2, 12.54 times 10. I have 10 to the third and 10 to the negative 6. So again, from what you recall, 10 to the third times 10 to the negative 6. I just add those up. I have 10 to the negative third. Well, so far so good, except I got to move the decimal. Only one number between 1 and 9 to the left. So I move one place here. So I have 1.254 times 10. Now I made this number small. I divided by 10 to make this smaller. Well, I divided by 10 here. I got to multiply by 10 here, go bigger. So I've got to add one. You know, so took one away from here. I got to add it over here. So now adding 1 to the negative 3, it's going to be 10 to the negative 2. And you have to kind of convince yourself that that's going to work. All right, number 23. 6.5, 1.3, I think 5, that becomes a 5. So it's 5.0. And this is going to be pretty quick. 10 to the negative 7th. I bring the negative 3 up, it's going to be a positive 3. So that should become 10 to the negative 4th. And this one's done with not too much fuss. And the last one here I'll show you. It's an exponent of an exponent. Remember, this 5 is going to the 3, and it's also going, this is sort of a coefficient of this. So if I, you know, for things we did before, if you had 3a to the 5th power, and it was to this, you know, the 6th power here, this is two bases. So the 6 had to go to the 3, and the 6 has to go to the 5 as well, or the a base. So this would be, you know, 3 to the 6 and a to the 30th power. Well, same thing here. This 5 has to go to the 3 and the 10 to the negative 9th. So 5 to the 3rd power, just like this. It's not a big deal. So 3 times 3 times 3 times 3, oops, times 3, 243. So this is 243. That's the 3 to the 5th power. And this, as you know, it's going to be 10 to the negative 45th. All right. This is not in proper scientific notation. Decimals here. I got to move it 2 places to the left. So I'm making it smaller. So 2.43. I made it smaller by moving it 2 places. I got to make this bigger, going in positive directions. So this would be times 10 to the negative 43 by adding 2 to it. I went 2 places to the left, making it smaller. I got to make this bigger by 2 places by coming up 2. All right, folks. Good luck.